today I will start with a subject that may be useful for the standard 6, 7, 8. Rather doing some sums, typical sums for a higher, I thought it would be better for the rest of my audience so that they can be attracted to my lessons. So I am trying to cover all part of the standards from starting from 5 onwards. So I will take up some of the common subjects that may be useful for your uh, for the exams that you will attend in your that means in board exams and the related exams. But the concept starts from the lower end lower classes, and that can be useful for up to the classes of 11, 12 also. But some variation may come, but the basics has to be the same. So the topic today I will take is cert. Okay, so higher classes students may be acquainted with that, but it would be useful for everybody to have a glance on it, so that the knowledge they are having, that can be also refreshed, and the students who are new to this term can have some good idea, the basics idea. So what is cert? So if I define it, I will define it like that: the irrational roots of a rational number. So this I find the simplest of all available definition of a cert. This is the simplest one, but to understand, you have to understand two terms, that is irrational and rational. What are those? Roots you probably understood, because uh, square root, cube root you might have come across in your study in earlier stage also. So roots you might have understood. I even know I will give you some examples so that it will be clear for you. But as of now, these two terms is very important to understand cert itself. So I will focus on these two terms first in this first session of this class, and later the consecutive videos I will come to the cert more in elaborate way, so that it will be very useful. So the number may be divided in so many ways, but this is the one kind of division where the number is divided into two such numbers, kind of numbers, which are called rational and irrational. Okay, so to understand that this is a kind of division, apart from that, number can be divided in some other ways also: whole number, your your real number, integers, and all that. So many things are there, but the uh, kind of division I am just discussing right now, it is divided into the concept of some characteristic of any number. So what is rational? The first simplest thing, I could represent this, I could represent a number in the form of a ratio, let's say p q by p, where q and p are integers. Okay, if I can represent a number in the ratio of two integers, then it is definitely a rational number. Okay, so if this is the thing, so these two terms word wise you can understand, this is opposite to each other. That means rational is just opposite to irrational. So there, if this is the definition of rational number, where I can represent a number in the ratio of two integers, that should not be a property for irrational number. That means I cannot represent any irrational number in the form of ratio of two integers. So that cannot be possible. Okay, the condition is same, that q and p are integers. So for example, if I take, that means if I take here, so the number would be 3 by 2. If you can see, 3 by 2, I am taking an example of a rational number, whereas if I take example of irrational number, if I say under root of 5, this is irrational number. So for example, I can say this can be represented in the form of 3 by 2, whereas root 5 cannot be represented in as a result. If I find root 5 cannot be represented in the form of two integers q by p. So this is the first part of the difference between rational and irrational. By the difference I can understand both the numbers carefully. Okay, so the second part, the first part is that it cannot be divided, it cannot be represented in the ratio of two integers, and this is irrational. If it is can be divided, can be represented in the form of ratio of two integers, then it is rational number. The second thing is that even if it is represented in the form of two integers, let's say q by p, then the value I will get would be a, let's say I am getting an integer here, decimal, some numbers of the decimal, and this number, the characteristics of this number would be like that, the decimal. So I would say the numbers it should be such that the number after decimal is to be recurring. That means recurring and finite. So this is the another characteristic of rational number, where if it is represented in the form of two integers, ratio of two integers, then if I divide it, I will get some number in decimal, where this number after the decimal would be a recurring and a finite number. That means what I have taken the example of 3 by 2 as a rational, so I would get the result in decimal as 1.5. So this is finite. That means this is not infinite number. Up to that I cannot divide. Means I will not get a finite number after decimal. I will get a finite number after decimal, and if at all it is repeated, that means some of the cases, if I find 10 upon 3 also a rational number, but in this case if I divide, that would come 3.33. So that means these numbers are recurring. That means it is repeating, the same number is repeating. So this kind of number also comes under the group of rational number. 10 by 3, 3.333, that way it will continue. Okay, so this kind of thing also can be represented. So in that case I will make it a finite by saying that as it is repeating, it not finish up, but it is repeating, recurring. So this kind of number also comes under the group of rational. Whereas if I take it, I cannot represent it number in form of q by p, that means ratio of two integers, such as root 5, root 3, like that. And if I get any, if I try to do the square root of this, I will not find something as a decimal number such that the numbers after the decimal will be a will be a recurring number. That means after the decimal I will not get any recurring number, because number will not be repeated. It will be a different number every time, and the number itself is not a finite. That means I will not get something which will repeat after some interval. It will be different every time, and it is not finite. So this kind of number also comes under the group of irrational number. Again, the irrational number can be divided into two ways. Okay, another kind of number, let's say I am taking example of pi. So this is also a example of two integers ratios. But if I see this is coming under the form of a decimal. The numbers after the decimal will not repeat, and it will go on changing the number infinitely. Just for example, if I take this 22 upon 7, if I want to divide it, that would come 3 7 the 21, 1, that will come 1 0 one time, 30 will come 30 will come, and 4 times 28 2, and then 2 times 6 will come, then your 8 times 40, then 5 times 50, and like that. That every number is changing, and it will be infinite. Nowhere it will come in a cycle that after some time it will repeat again in the same way. So it won't go like that. So this kind of number also comes under the irrational number. But this kind of number, let's say I'm taking pi, e, this kind of thing are called Euler's number. Euler's number. Okay, so this kind of comes under Euler's number. Why I am saying this? Because as per definition, surd is such that I will get a irrational root of a rational number. That means if I do it root 5, let's say, I will get some result that would be irrational. That means after if it would definitely come in a decimal, but the decimal will come infinitely without repeating the numbers. But those numbers don't come in this kind of numbers. These are different from this kind of Euler's numbers. This is a perfect number, comes under irrational. So I will get something which is a irrational root of a rational number, because 5 is a rational number altogether. So this is the basics for surd to understand. So I will stop here. In next class I will explain further on surds, different kind of surds, their rules, how to solve a problem. So that I will bring you for you. As of now, you understand this much. Go through this lesson and try to understand the concept. Thank you. Thank you for now. Good night.